Inverse function is obtained from a function by switching the input and output. Okay? So let's say you have a function g of x that sends 1, 2, 3 into, say, 7, 8, 9 in the following way. 1 goes to 9, 2 goes to 7, and 3 goes to 8. Okay. Now, looking at this, tell me what g inverse of 9 is. 1, right? See, g of 1 is 9. What does an inverse function do? It switches the input and output. You switch the input and output, you get a new function, which if you tell the output of the old function, it gives you the input of the old function. Let's do one more. G inverse of 8 would be?
3.
3. Good. So that's what an inverse function is. Yes?
How would you know where the arrows go, though?
Oh, no, I'm so in a math question, there's something given,
Okay.
and then there's the question, right?
Okay.
So given is given. You're told that, oh, I mean, somebody comes up to you and say, oh, I have this function, it looks like this. Then the question is, can you tell me what g inverse of 9 is? What g inverse of 8 is? Assuming that this is something that's known. Yeah. So, yeah, I just pulled up an example. All right. So let's quickly move on to finding the inverse function. Suppose your function f of x is 3x plus 1. And the question is, what is the formula for f inverse of x? Okay. Well, the way you solve this is by first introducing the y output as y, and x is the input. So whatever that function, the inverse function is, see, in the old function, x was the input and y was the output computed by doing 3x plus 1, right? In here, we're calling the input as x, but that's really the y in the old function. In other words, if you want to go from a function to its inverse, what happens to input and output? They flip, they switch, right? So the first step into finding the formula for the inverse is to switch x and y. So it's really 2 steps. Step 1, introduce y and flip x and y. So you see, there was no y here, and I just introduced the y, right? And then now you're going to flip these two, and you get x equals to 3y plus 1. So whenever you see a y, you put an x. Whenever you see an x, you put a y, right? So that's step 1. And step 2 is solve for y. Because, look, in this new function, this is your input and that's your output. And when you want the formula for a function, you always want to express your output as a function of input, right? So that's why you have to solve this. You subtract 1 and divide by 3, and you get y equals to x divided by 3, or 1/3 times x. Well, dividing by 3 is same as multiplying by 1/3, right? So I multiply 1/3 both sides. So I get 1/3 times x and 1/3 times 1, which is 1/3. So that's the formula. And therefore, finally, the answer is f inverse of x is 1/3 of x minus 1/3. So that's how you find the inverse function. Yes?
Can you just explain how you get to the 1/3 x minus from that again?
Oh, okay, yeah. So the way I go from here to there is by multiplying by 1/3 both sides. right?
Mm-hmm.
What's 3 times 1/3?
1.
1, right?
Oh, yeah.
3
Sorry,
divided by
yeah,
3
1.
is 1, right? So y is equal to 1/3 x minus 1. Actually, this could be a perfectly okay solution.
Mhm.
But what I did was I multiplied this
Okay.
and I got 1/3 of x minus 1/3. Yes?
What if you just divide it by 3? What would that
That's
be?
the same exact thing. Oh, yeah, yeah. So
Then you would have x minus 1 over 3.
right, that's also equivalent, right? So your suggestion is you can divide both sides by 3. This will cancel and you get y equals to x minus 1 over 3. And by the way, x minus 1 over 3, 1/3 times x minus 1, 1/3 x minus 1/3, these three are all equivalent. They're exactly the same functions. You can check it by plugging in random values. You'll see that the three things will all produce the same answer. So once you have those formulas, then you have to write your answer as f of x equal to something. And if you choose this one, then you can write it as x minus 1 over 3. That's fine too. Okay. So any one of these three could be considered as a correct solution. All right, and then lastly, hopefully that wasn't too confusing. Lastly, there's an important way to check whether your formula is correct or not, which is that to check if you compose f with f inverse, you know, this is in mathematical operations, it's called the composition of functions. Okay, so this is called the composition of functions, but that's not my point. If you plugged in one into the other, then you should be getting your x back. And that's true if you do it the opposite way. Now, let me quickly explain why this is always true. Okay, so remember in our 1, 2, 3, 7, 8, 9 example, and we had this example. So think about this. What's f inverse of 8? And then you apply f again. All right, let's do one by one. What's f inverse of 8?
3.
3. What's f of 3?
8.
8.
Oh.
So what happened? You start from 8, went back to 3, and then went back to 8 again, right? So of course, if you do this, what are you going to get? X will go to some y and it will come back, so you're going to get the x again, right? Yeah. Same thing, if you do it the opposite way, if you do f inverse of f of 3, well, let's do something else. F of 1. What's f of 1? 9. And then what's f inverse of 9? 1. Okay. So in other words, if you have an inverse function and the original function, when you compose them, they cancel out. They kind of cancel each other out, and then you get the x back. Now that's a great way to check whether you got the correct answer. So let's do the check. What would be f of f inverse of x? Well, first, f inverse of x is x minus 1 over 3, so you can replace f inverse of x by this. Then, that means I have to plug in into this x, this complicated thing. How do you do that? Well, see, f of x is 3 times x plus 1. That's what this definition is saying, right? Now you plug in x minus 1 over 3 there. That means x minus 1 over 3 goes here, right? And now can you simplify this? 3 cancels. And you get x minus 1 plus 1, which is x. Good. So we verify that it's true, okay? You actually have to do both. F inverse of f of x, then f of x is 3x plus 1, right? And then you're basically plugging into this x, 3x plus 1, so it's 3x plus 1 minus 1 divided by 3. 1 cancels, and you get 3x divided by 3, which is equal to x. Right? You see that? Okay. So In the exam, if you somehow got the answer and you wanted like 100% correctness, then you would do this, and you'll be able to verify whether you got the correct answer or not.